Hey everyone, glad to see you all here at KubeCon London today. Hopefully you managed to catch some good talks already and are just not too sleepy after lunch. So in this talk, we will be going to taking you through Prometheus v3, what's new in that, and talk a bit about the future work beyond v3.
Cool, so hi everyone, I'm Fiona. I'm a software engineer at Grafana Labs, and I mostly work on Prometheus and Grafana Mimir there. In Prometheus, I've worked on stuff like out-of-order native histograms, as well as helping to coordinate the v3 release, and I've recently become a Prometheus team member, so yay for me, I guess. This picture is from the last time I was here at the Excel Center, so that was a couple of years ago, and I was doing a sports event, and my watch picked up that I may have been a little stressed, so I'm hoping this talk will be less nerve-wracking than that.
Yeah, and my name is Saswata Mukherjee. I'm a senior software engineer at Red Hat, where I work on monitoring platforms, largely based around Thanos and Prometheus. I'm a maintainer of Thanos as well, and a newly minted Prometheus team member. I also help maintain certain other CNCF adjacent Go tools and libraries, and you can find me as Saswata code pretty much anywhere. A little bit of audience participation to start, which we all know and love. So for Prometheus deep dive talks, we like to do this fun exercise before we start. So first, raise your hands if you know what Prometheus is. Oh, very nice, cool. Keep your hand up if you use Prometheus. Okay, and now keep your hand up if you use Prometheus at scale. Awesome. One last question then. Now, put or keep your hand up if you know what the plural of Prometheus is. Awesome. Okay, cool. Some real experts here, I see. But yeah, if you didn't know, it's Prometheus, and there's a fun talk on why. But yeah, now we know the plural is Prometheus. What even is it? Just as a bit of a recap. So it's a metrics-based monitoring and alerting toolkit created at SoundCloud in 2012, and it joined the CNCF in 2016 as the second project to do so after Kubernetes. If you're curious about the backstory, there's a nice documentary on it on YouTube, which goes through its inception and its journey to becoming the widely used open source project it is today. What Prometheus offers is a rich instrumentation ecosystem, data collection and storage, and querying, alerting, and visualization support. To dive a bit deeper, for data collection, you have exporters which expose metrics in the Prometheus format. There are exporters for a bunch of different things like databases and servers and stuff. And then there's some software like Kubernetes that also expose Prometheus metrics directly. Prometheus scrapes these exporters, periodically pulling the metrics from the exporters' endpoints. And to make scraping easier, there's service discovery to automatically find the endpoints to scrape. For example, it can query the Kubernetes API to automatically discover pods, services, and so on to find the things exposing metrics. And then the data is ingested and stored in a time series database, TSDB for short, where it can then be queried with the Prometheus query language, PromQL, to be visualized and alerted on, which is, very important for understanding your system and for ensuring that production isn't on fire. So the latest version of Prometheus, 3.0, was released in November last year, 7 years after the 2.0 release. So major developments include a new UI, L2L compatibility, a new ingestion protocol, native histograms, and some breaking changes to improve querying and also to remove tech debt. And we'll be covering these areas in the talk. 5 months on, there continues to be additional updates and a few minor version bumps. So in this talk, we'll also go through some of the things that have happened since 3.0, as well as looking forward to the exciting things happening in the future. So with that nice refresher on Prometheus out of the way, let's talk about one of the most discernible changes introduced in v3, which is the new UI. And yeah, as you can see, it is beautiful. You can stare at it for hours, which makes for a much nicer on-call experience for everyone.
So this improved look and feel is the result of a large stream of work undertaken by Julius last year to modernize the Prometheus UI, making it less cluttered, more consistent, and just a lot more easier to navigate. To share a few technical details behind the UI, it has been completely rewritten using React along with the Mantine UI framework, replacing the old Bootstrap-based setup. And so this new stack is much more developer-friendly and modern, and it also brings in some powerful features adapted from the upstream Prometheus project, making the overall experience much more intuitive. So you can see in the new UI, a lot of the query panel and the global options are now organized neatly and sort of hidden away, making it much less cluttered. And it also supports a new minimalist color scheme for the alerts and targets pages instead of what was there previously, which were sort of like jarring bars of colors. Another one of the standout features is adapted from Prometheus. It's the new query explanation view. And so it's powered by a brand new Prometheus API endpoint that returns the abstract syntax tree of your PromQL query. And this view breaks down that query tree visually and enriches it with documentation in line so that you know exactly what you're querying and why you're querying. And we all know PromQL joins are also super confusing at times. So this query explanation view helps you too by allowing you to sort of visualize exactly how you are joining series together by describing the match groups on both the left and right-hand side of all of your binary operators. Now, PromQL syntax errors also become kind of easy to spot and fix with this explanation view, as it points out the issues with detailed descriptions of every part of your query. And finally, you also get a completely new and revamped Query Builder UI that not only helps you discover your metrics and all of the metadata associated with it, but also helps you select the appropriate labels that you want and build patches directly from the UI itself to build your query. And there's still a lot of work being done on the UI. We have already had a bunch of work done on the graph views, such as vertical grid lines and clipboard functionality. There are still in progress work items to implement UTF-8 query auto-completion, as well as add the ability to render heat maps and native histograms. And we would also love to hear feedback from the community on how using the new UI feels and what they would like to modify or change.
Next, so let's talk about native histograms now. So historically, if you wanted to measure things like the latency of requests in Prometheus, you'd use classic histograms. This is where each bucket in the histogram is represented by a separate sample with a label defining the bucket boundary and additional count and sum metrics, samples too. Each of these samples is just a simple float value. A new feature, native histograms, stores the entire distribution, so all the bucket counts, the sum, and the number of observations within a single complex sample type. So native histograms are more efficient and cheaper to store than classic histograms. Unlike classic histograms, where you have to manually define bucket boundaries, native histograms handle this automatically with preset boundaries based on exponential growth, so you avoid possibly choosing inappropriate bucket sizes for your data. You're also able to configure the accuracy of native histograms if you want. So this shows an example of querying native histograms via the new Prometheus UI, where this graph shows the bucket counts of the native histograms. And you can see the bucket boundaries in the table there. And this shows querying for the 50th percentile of a native histogram. Note that there are some slight changes to querying for native versus classic histograms. You don't need to group by the LE label when querying for a native histogram, for example. So currently, native histograms are still experimental, but it's basically stable and there shouldn't be any big breaking changes. Since 3.0, there's been additional work like improving how functions aggregate native histograms, and still to do is finalizing the text format and some additional refinements to edge cases. There's also a heat map UI in progress for better visualization of the distribution of histograms. Lastly, Custom buckets support for native histograms is in progress. While native histograms automatically define bucket boundaries, sometimes it's useful to have the manual control bucket boundaries instead. So custom buckets extends the native histogram format to support this case, so you can get the efficiency of native histograms with the explicit bucket boundary configuration of classic histograms. These will also make it easier to migrate from classic histograms to native ones, so with scraping able to automatically convert classic histograms to native ones with custom buckets. And as a heads up though, this feature is still very experimental at the moment. If you're interested, there is a draft native histogram specification that goes into a lot more detail about native histograms and how to use them and how to configure than I have here.
Up next, let's talk about one of my favorite topics, which is Remote Write 2.0. So if you're not really familiar with Prometheus Remote Write, it might be good to first start by explaining what Remote Write 1.0 is or was. It is a remote storage protocol used by Prometheus-compatible senders to send real-time scraped metrics to remote write receivers, who can then ingest that in some Prometheus format time series database. And so the protocol sends snappy encoded protobuf messages over HTTP with back-off retry semantics based on the receiver's response codes. Prometheus could send and receive it, and other scalable monitoring tools like Thanos, Cortex, Mimir are capable of ingesting that data and writing it to their own respective TSDBs. And this protocol has been widely adopted not only by these tools, but also by vendors as well, and has proven to be very useful for real-time metric streaming. The protobuf definitions for Remote Write 1.0 are pretty simple and look something like this. And so the samples being timestamp and float value pairs that are associated with a set of labels. You can optionally also include some metadata in separate requests. And the protobufs, by the way, are also available via the buff schema registry, which that QR code is for. Now, Remote Write 1.0 is immensely successful, but it really could be better in terms of network bandwidth and efficiency, as well as support for new Prometheus features, and maybe also leave room for changes in the long run. And the Remote Write 2.0 iteration does exactly that. So as the new specification dictates, we have quite a few changes over 1.0. It's still protobuf over HTTP, but Remote Write 2.0 now sends data by string interning all the various label data as well as the metadata, which vastly reduces the actual request size and the network bandwidth costs. The spec now also includes fields for the latest Prometheus features, such as native histograms and created timestamps, and even supports sending relevant metadata directly alongside the time series. Furthermore, we now have explicit partial write handling directly within the spec, so receivers can respond with the exact partial write error statistics for different types of samples in that remote write request using HTTP headers. And senders can use these response headers to basically log errors and retry accordingly. As you can see in the new Remote Write 2.0 protobuf, there is a symbols field in that request, which is essentially a symbols table mapping all of the labels, including metadata strings. And the rest of the fields can then refer to the indices of that symbol table, thereby leading to just much smaller request bodies. And yes, this prot is also available in the buff schema registry. Now, supporting Remote Write 2.0 on your existing 1.0 receiver does not really mean that you would need a new endpoint, as this uses HTTP content negotiation using the content type header, so which would basically contain the fully qualified name of the protobuf being used, and the receiver can use that to determine the version of the remote write request. We have also been hard at work trying to make this much easier to adopt in the long run, and to that end, we have a new experimental library built directly into the Prometheus client Golang library, which kind of allows you to construct Remote Write 2.0 compatible senders and receivers easily without having to manually ensure compliance to the complicated spec. The idea is for projects, including Prometheus and other downstreams such as Thanos, Cortex, and Mimir, to use this library and support Remote Write v2. As per the benchmarking done by Bartek and Callum, the initial authors of Remote Write 2.0 during the implementation and their PromCon talk, you can see the efficiency gains you would have by switching to Remote Write v2, as well both on the bandwidth side as well as on the serialization levels. And we are only getting started with this. With the growing adoption of Remote Write v2, the next step would be to declare it non-experimental. There's also some work going into actually sending created timestamps via Remote Write in Prometheus, as well as addressing certain efficiency issues with metadata, and maybe seeing how that can evolve with type and unit metadata labels. And the purpose of having this new flexible protocol is so that we can experiment more with various compressions and maybe even formats like Apache Arrow in the future.
With OpenTelemetry becoming increasingly important, we've been actively committed to ensuring Prometheus is a great backend for OTel. In addition to scraping a remote write, Prometheus now allows you to directly push metrics in the OTLP format to the OTLP v1 metrics endpoint. Prometheus will then automatically translate these OTLP metrics into its native Prometheus format. There's a guide on how to configure this, best practices, and information on resource attribute handling on the Prometheus website, linked in this slide. And one thing we've seen is that out of order tends to be a lot more common for data received via the OTLP endpoint, and as part of 3.0, out of order ingestion in Prometheus was marked as stable. Also, excitingly, with 3.0, UTF-8 support was enabled by default. Previously, Prometheus metric and label names were limited to letters, numbers, colons, and underscores. But with recent changes, we now support any UTF-8 character. This makes integrating with OTel nicer. Metrics can now preserve dots, for example, which are commonly used in OTel metric names and labels, rather than replacing them with underscores. So there's a translation strategy setting to configure this. UTF-8 support, of course, also means emoji, which is personally the more exciting use case for myself. Note that there is new syntax for UTF-8 metric and label names. Metric names with UTF-8 have to go inside the curly braces, and metric and label names with these characters have to be quoted. So UTF-8 support is still being refined, as not all tooling supports it or supports it consistently. So for example, we are looking for volunteers to add UTF-8 support to the Prometheus Ruby client, and there's also additional work and fine-tuning with OTel. We noticed, for example, recently that with UTF-8 turned on, the OTel collector would be exposing metric names with underscores, but label names with the dots. And next, there's currently a proposal for adding type and unit of a metric as metadata. Right now, OTel type and unit are just shoved into the metric name, which isn't something that everyone likes. And having unit and type treated specially could improve the user experience and allow for more type-aware functions. To more fully support OTel metric ingestion, we're also looking into supporting delta temporality in Prometheus. So currently there's an experimental option to convert delta metrics pushed through the OTLP endpoint into cumulative ones to be stored in Prometheus, but we're also progressing with another option that avoids the conversion altogether, so native delta support, in other words. We've gone through the major features for 3.0, so just to wrap it up, we have this screenshot of an OTel exponential histogram that was ingested via the OTLP endpoint and converted into a Prometheus native histogram with the dots in the name preserved and, of course, queried on the new UI. And now we get to the final part of the v3 update, the breaking changes. With the new major version, we saw an opportunity to make some breaking changes and clean up Prometheus a bit. Most of these changes were focused on housekeeping, removing some old flags and tech debt, and also making a few refinements to PromQL. I could go through everything line by line, but that's probably not the best use of time for everyone. There is a migration guide that goes into more detail about everything if you're looking to upgrade from v2 though, so yeah, don't worry about reading all that teeny text up there. I do have a couple of key call-outs though, based on issues we've seen people hit with the update to v3. So the first thing is that range and subquery selectors are now left open. previously the sample at the start timestamp was included in the range, and now it isn't. So in subqueries where the range and the resolution are the same, v2 will usually return 2 points while v3 only returns 1. So this can cause issues if the subquery is wrapped in a function that needs 2 points, like rate. Suddenly you might just not see any data. The second thing is when scraping, the implicit fallback to the Prometheus text format has been removed. So previously, if the content type from the target was missing or unrecognized, Prometheus would assume it was using the standard Prometheus text format. However, this could lead to metrics in the open metrics formats to be misparsed without erroring. So therefore, v3 will actually error if the format is unclear. We've seen a few instances where users start hitting this error when upgrading to v3, and the ideal fix is to set the right content type. But there's also a fallback scrape protocol setting you can explicitly configure in Prometheus to go back to the previous behavior.
So we also have some interesting community and governance updates that might have been shared a few times, but it's always good to reiterate these things. So in case you missed it, the Prometheus team recently agreed to add 22 new members, including the both of us. So a lot of them have been instrumental in getting v3 out the door. Some are working on things in the ecosystem and have been working hard to make sure that using Prometheus is a holistically enjoyable experience for everyone involved. And we are also updating our governance model a bit. So instead of adding team members rarely and having to gain consensus for all small decisions from that many members, we would have a much smaller steering committee that would make crucial decisions about the future of the Prometheus project. And it will be a committee that people can get elected to as well as be rotated out of. Alongside that, we are also introducing a contributor ladder framework to recognize key contributors within the community and get them involved much quicker. So if you have ever gotten a PR bunch in any Prometheus repo, congratulations, you are now a contributor. And based on further contributions, going from member to maintainer is also fully possible and just a much less daunting experience than what was there previously. And if that excites you and you really would love to start contributing and getting more involved, well, we have a lot of future work ahead. So a bit of a nice segue there. We have a lot going on in our community and with several different changes underway, and we would like you to be a part of that as well, especially if those changes can help you in your context. We have initiatives to support OpenTelemetry and OTLP signals in a way which makes Prometheus the best backend for OTLP metrics. The work going on there involves tricky concepts around delta temporality, resource attributes, even created timestamps, and so much more. And one of the key features to enable OTLP, which was UTF-8, now needs efforts on every single Prometheus client library. We have proposals for adding secret providers to Prometheus or exploring using type and units as actual labels instead of metadata. And there's a ton of work going on behind the scenes for native histograms around implementing custom buckets and for Remote Write 2.0 as well. And people don't stop innovating there. We now even have a working group to explore a new TSDB format powered by Apache Parquet. And the reason I mention all of this is to highlight that there's room for everyone to contribute to these in-depth topics and bring in their fresh perspectives and experiences. And the easiest way to reach out to us is to basically explore the myriad of channels we have on CNCF, which are quite a lot. And each has its own topics. And you can also grab us here at the Prometheus booth in the Project Pavilion, which is the 9A kiosk for more in-depth conversation. So, any questions?
Regarding PromQL, were you considering implementing the labels into the query? For example, if I have a recording rule and I would like to have a label with its SLO, then it would much be easier for me to just replace the value, the threshold, with the label value instead of hard coding it.
So not sure I fully understood your question. Do you mean like whether you can add a label to a recording rule, or?
I mean, in such case that I have a recording rule and I have an alerting threshold, and I would like the rule to validate as true if it extends the value of the label. Were you considering such cases?
I'm not, just to understand, so this is sort of like you have the label value as the value essentially of the result of the metric. I'm not sure if there's like any active discussion on this. I think it's actually a case that I was looking into a bit myself or something a while ago, but I guess at that point there wasn't like enough of an incentive for us to really look at that. So I guess it's like if there's enough use cases for it, then maybe it's something that we could implement, but it's not actively done. Oh, there's a question there. At the back, well, further down, there's a in the middle. Just look you through the.
Thank you. Yeah, just a question. So both remote write and hotel allow to push metrics to Prometheus. So is there any reason to use one over the other?
Really depends on what you want to monitor. I guess if your application is instrumented with OTel, it might make sense for you to send OTLP. Whereas if it's instrumented with client Golang or something similar, it might make sense for you to just scrape using Prometheus or remote write. Anyone else? Going once, going twice. Okay, thank you.